Okay, we got a practice problem here for the washer method. It says find the volume of the region bounded by y equals 2 square roots of 3, y equals 2, and x equals 0. And we're going to rotate that around the x-axis. So the best place to start would be to draw a little graph if we can. We'll try. So a little xy graph. So let's see here. It says we're going to go up to y equals 2. And x equals 0. So y equals 2 is up here. Y equals 2. And then we've got y equals 2 square roots of x. So in that case, when we plug in 0, we get 0. When we plug in 1, it looks like we would get 2. Because square root of 1 would be 1, 2. So up here, so very quickly, I mean this thing looks kind of like a regular square root, but very quickly it looks like we have a region here, and of course x equals 0 is the y-axis. So we're going to take this little region here in the first quadrant and rotate it around the x-axis, and that's going to leave a gap in certain places. So if we take a look at this, what we can tell is we have a large radius from that rotation point right here. The large radius would go all the way out to the y equals 2. So that radius would be 2. That's the outer radius. The little r, the inner radius, would be the curve that we got where we meet it first. That would be the y equals 2 square roots of x. And since we are rotating around the x-axis, we're going to want it in terms of x, so it'll be good to just go ahead and use 2 square roots of x. That is the inner. Okay, so that's our outer radius and our inner radius. Okay, so up here, all the way out to the red line, that's the big R, and going into the curve, that's the little r. Okay. So think about that rotation, but let's go ahead and set it up. So pi times the integral. So for x, it looks like it's going to go from 0 to 1 in this little region down here. Okay, so from 0 to 1. And then what do we have? We have the outer radius of 2, and that'll be squared, minus the inner radius of 2 square roots of x, and that'll be squared dx. Okay, so here's the outer, the big R, and here's the inner, the little r. So we'll push through, we'll clean up a little bit. So this will be pi times the integral from 0 to 1 of 4 minus, and when I square 2 square roots of x, I'll get 4x. Okay, so it looks like a very easy integration. 4 minus 4x as far as the thing that I'm going to integrate. So integrate, pi stays there, 4 will become 4x, negative 4x will become 2x squared, or minus 2x squared, and that will be from 0 to 1, and we're ready to plug in. Alright, so we are finding the outer shell and the inner shell, putting it all together. So let x equal 1. Okay, for that outer radius, so I get pi times 4 minus 2. I'm going to subtract off when I let x equal 0. And it's been fairly common that when we plug in 0, it seems like we get 0 all the time. That's not a definitive thing. It just seems to be fairly routine in the ones we've done. So 4 minus 2 is 2, so the number we get out of this is 2 pi. That would be the volume from rotating this little figure around the x-axis. Okay, thank you.